Okay, let's get started. Hope you all had a good long weekend. So I made an announcement here. I posted assignment 2, and you should be able to see it right here. We're going to in and out on assignment 2, so hopefully that one's kind of fun. Any questions? Yeah.
What exactly are we doing for assignment 1?
So what are we doing for assignment 1? Yeah, you're writing the C++ program, and then what is the C++ program trying to do? Sorry? Right, so you input the values as specified in the PDF, which are the center locations of a player and an obstacle, and then you want to figure out the distance separating them. So you can think of them as two spheres, and then you want to print out the distance between the gap between the two spheres, if there is any. So you figure out what is the distance between the 2 points, and you can just use Euclidean distance for that. And then after that, you subtract the 2 radii from it. So if one sphere was located at the origin 0, 0, 0, and another one was located at 1, 1, 1, so anyone happen to know the distance from 0, 0, 0 to 1, 1, 1? Yeah, I think it's root 3. And so let's say that the radius of each of the spheres was 1/4. So then what you would print out is root 3 minus 1/4 minus 1/4 for each of the 2 radii. And that's all you need to print. But you have to pass the test cases, so you have to print what is specified. So like the distance between them is such and such. So yeah, you had a question?
Yeah, for the answer for the distance is supposed to be from different places, so we have to float around it. But then so what we did was we do search online for that.
Yeah.
So, and then we just we cite it to that, right?
Right. So and then you also have to format the output to 4 decimal places. And so I didn't explicitly teach you how to actually do that. So that's where you have to think, because I can't teach every single thing, you need to be able to understand how to look up additional libraries that are useful to you, especially in this case. And so once you find that and you see, okay, here's how I actually do it. How do you cite it? Put a comment in the code. Comment saying, I got this, the way to do 4 decimal places from this URL, and that's it. Yeah. Oh, no. So there's no formatting requirements on the code, but try to make it so that you get into the habit of writing good-looking code, because if you, at some other point, are going to be looking at your code again, you want to be able to understand it. I've had this problem before where I've left code that I haven't touched for 6 months, and then I look at it and I have no idea what it does, even though I wrote it. So being able to document your code, make it look readable, and understand what it's supposed to do, that is a good habit to get into. But there's no requirement. Yeah. What's that? Yeah. Other questions? When's assignment 1 due? Today. So any other questions? Or about last lecture or anything? Okay, so let's get back into material then. So last time, way back when, we were talking about these char things and strings, which are basically just characters. So a char is a single character, a string is a bunch of characters, right? And then we talked about certain properties of strings, ways that we could work with strings. If we want to make a variable that holds a string value, then we gotta declare its type to be string also. So instead of just int or double or whatever, we would put string on the left side instead of those things. And then if we want to print them, we just use cout like usual. There's no difference here. You don't have to do anything special. And you may wonder, well, what if I make my own custom type, as we will do later? How does cout know what to do? And that gets to something that's really fundamental in the language. How does cout know what to print? Because if it gets a char or an int, they are literally the same data, but cout, as we saw last time, can handle them differently because one of them is a char, one of them is an int. So hopefully we'll get to that near the end of the class. But if we want to input a string, we can use cin just like usual, but the way that cin works by default is that it goes up until it sees a space, and after that point, it just treats that first block as the input so far. So if you want to enter a string that does have a space in it, then you should use getLine instead. So what getLine does is it gets the entire line. So a line here, remember, is everything up until when you push the enter key. So anything in between is fair game. Whereas cin parses everything based off where the spaces are. So it treats everything up until a space as the input. Here are some ways to input a character. I'm not going to really test on this. This is just for your benefit. The one that we'll pretty much use, if we're going to use it at all, is just the normal cin one. But there are other ways that you can get chars. And if you want to ignore some characters, you can. We're not going to actually use this. This is just for your benefit, and I'm not going to test on it. If you want to know the length of a string, we saw last time, is the way that you calculate it is the string variable name, which one in this case is called first pres. If we want to know the length of that string, we would just say first pres, and then we call the dot operator on this variable. So the dot operator means we're going to ask a question about this object, in a sense. So we're going to ask the question, what is your length? And so the function call, which will give us the length that we want, is called length, oddly enough. And then you have to put parentheses here because it's a function. We haven't talked about functions yet, but so that's basically all you need to do. The variable name called string dot length and with parentheses, and that returns to you an int, which tells you the size of the string, the number of characters in the string. So in this case, there are 17 characters in this string. So if you count 6 for George, 1 for the space, and then 10 for Washington, that's 17 total. It doesn't count the null terminator at the end because it's not really part of the string. It's just a side effect of having strings. Okay, so that's what we've talked about last time. So this function we're not going to actually use. I didn't use it last semester, but again, it's for your benefit. Oops. So this function called assign, all it does is it puts characters into a string. So if you want to, for example, print like a menu, say for like assignment 2, one of the things that you'll do is you'll print a line of either equal signs or dashes, I don't know which, but you're going to enter like a whole bunch of dashes in a row. Well, you could just say cout dash, 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 all in one string if you wanted to. But if you wanted to put that into a string, it might be kind of weird to do that. So what you can do instead is start with a string that doesn't have any characters at all. Say right here, this equals thing. And then we call dot assign. And then you're going to pass in 2 things to it. The number of the character you want to put in. And then the second one is what character you want to put. So if you want to, so when we do this cout right here, it's going to print 80 equal signs in a row. So instead of saying string equals assignment operator, the string with 80 equal signs written explicitly there, you can just do this, so it's a lot easier. And the nice thing is that this can adapt to user input. So maybe you can have the user input a number n, let's say, and then they can dictate how many equals that they're going to output. So we can actually show that in action. So let's just copy this example in. So instead of just saying 80 here, we can just say int n that we're going to eventually get from the user. I don't know what happened there. I don't know why everything's off by 1, but okay, so how do I input a number from the user? Let's have no prompt here. How do I input something? Cn. So Cn n, and then let's just say I want to print n equal signs in a row, and that's it. So what do I do to change it and change this program? I would change 80 to n. So remember, assign just puts this number of this character into the string. So in this case, it's going to put n equal signs into the string. So if we compile and run, so it's waiting for my input, so let's just say 1,000, and then it prints 1,000 equal signs. So this is an example of having an example program like this and generalizing it to allow for user input. So before, it just printed 80 equal signs regardless of what the user would have done. But here we have made it so that the user's now in control, so that they can input as many equal signs and have them be printed as they want. Okay, so we're not going to really use assign at all in this class, but it's just for your benefit. Okay, so this might be one of the most important concepts in the class. So, and it's super, super simple, but it's nevertheless very important. So, what is this thing bool? So, a bool is just something that is true or something that's false. It is either true or it's false. Okay? So, that's it. That's literally all it is. So a bool is like a char or a char. It's represented as an integer in the very same way. But in general, what happens is that false is represented by 0 and true is represented by 1. So this is not technically exact, because technically what happens is false is represented by 0 and true is represented by anything other than 0. So, but if you just say 1, that's enough. But since C++ is more user-friendly than a lower-level language might be, we actually use the keywords true and false. We don't actually write 0 and 1 because it's a lot easier to read. So I could have said bool all done equals 1, and bool all finished equals 0. I could have done that, but I can just say true and false here. This is a lot cleaner and easier to understand. I think that's it. So why is this so important? So we're going to get to this starting in the next chapter, where we can say, if some condition is true, which will evaluate to a bool value, if some condition is true, then I want to execute this code. If this condition is not true, I won't execute this code. So now, by using bools, we can actually get conditional code execution. If it's like, maybe we can say, we can have a weather type application where, depending on what the weather is outside, we can recommend to the user, you should wear this if it's hot, or if it's mild, or if it's cold. You can conditionally print different things based off of what the user entered, which is kind of nice. And bools are the underlying principle behind all of that, which is kind of nice. Any questions about bools? Yeah.
When I think of like bool, it's like an if statement, but then I don't
Yep.
understand how like identifier is a bool. How would you use this statement?
So a good question. So we'll get to that when we get to if statements. But to answer your question, sometimes what you would want is something called a flag, which is I'm going to initially set this bool to be true, let's say. And then I'm going to execute some code, and if something happens, I'm going to set the flag to false. And then later, after all that's done, I check the flag. So I need a variable for that. But we're going to get to all that. Any other questions about bools? It really is this simple. It's just true or false. That's all it is. Okay, so sometimes we talked about these integer data types like int, long, short, char, whatever. Depending on the machine, so actually some of you have experienced this, where you were trying to get VirtualBox to install, but some error popped up about like using 64-bit. And how many of that did that happen? Okay, so quite a few. So what happens there is sometimes the size of an integer depends on the architecture. So I said integers usually 32 bits, but on some architectures it's 64. Sometimes it's less. Sometimes longs are, it could be actually different depending on the architecture. So that could be a gigantic problem if you're trying to port something over to a different platform, because if the sizes of things are different, then one, performance might change, two, corruption might happen, because if you're storing something as a 64-bit integer and you're trying to run it on a 32-bit machine, then half of those bits are going to be cut off if I just try to port it over. So what you would want to figure out is, let's figure out the size of, say, an integer or anything really. Let's figure out the size of something. And so we can have our code be based on the size of whatever the thing is. So if the size of an integer is 32 bits, maybe we do this. If the size of an integer is 64 bits, we do this instead. We can actually conditionally execute code based off the size of an integer, let's say. So the way you do this is you call the size of operator. Okay? So this tells you the number of bytes in some data type. So the way that you can do this is, what you do is either you can pass the type directly in, so size of float, or I can pass a variable in directly, in this case amount, which is the double here. So if we run this, of course it depends on the machine, so let's actually just figure out what it actually is on this machine. So let's save and compile. So okay, so a float here on my machine is 4 bytes, and the amount, which is what type is amount? It's a double. So a double always has 8 bytes on my machine. So 4 bytes, how many bits is 4 bytes? 32 times 8. 8 bytes is 64. Okay, so then maybe we want to know int and then maybe long, for example. Okay, so I didn't actually change the strings here, but the first one is int, and then the second one is long. So on my machine, an int is 32 bits, and a long, in this case, is 64 bits. So then you can actually figure out on your machine, depending on the size of the int, maybe we need to do something special in that case. But in general, it's usually 32 bits for int on most machines. Yeah.
Put for the first one the float, which is the variable type, and then the second one amount, which is the name. So you can put a name or the variable type.
Yeah, that's what it's, yeah. So you can either put the type or the actual variable. So what actually happens is if you pass in a variable, it looks up the type anyway. So then it just does the same thing. Any questions about Sizeof? Okay. So here is probably either my favorite or second favorite part of C++, which is auto. So I want to show you something. A lot of things, but let's just look at this. So if I do this code, and then maybe let's just do cout x or something. Does it? I'm not going to compile and run this, but does this code compile and run? Yeah. So what is the type on the right side here? It's an integer. What's the type on the left side? Int. Will the program compile now? No. Why? Why won't it compile? Well, let's see. What's the type on the left side? String. Sorry, int. What is the thing on the left side? String. Are those the same thing? Are strings and ints the same thing? No. Well, why do I have to type this on the left side? Well, maybe I just made a mistake. What if I did something that's silently wrong? So the maximum size of a, let's just do short, for example. So a short's maximum size, so a short has, let's see, it has, actually we can figure that out. Let's see, what's the size of a short on this machine? Let's not actually guess, let's actually figure it out. So I didn't put a new line, it's 2 bytes. So so how many bits are in 2 bytes? To this 16. So what is the maximum possible size of a short? Short is a sign type. It's to the, not 16, 15, because of the 1 bit for the sign bit. So what if I just did this? Let's see, equals something way longer than the type. What if I did something like that? So the compiler in this case will actually catch you. So it'll tell you that this is too large. But let's just say that instead we have a short x and then we cint our x. Could I enter something like 99999 whatever, and this will work? Well, if I actually try this, then, oops. Oh, I didn't save. If I tried this and I entered a huge number, then it prints something, right? It's actually truncating it, but we won't worry about that. But there, as you could see, that there's some type of silent conversion happening here. I want to represent this gigantic number, but I'm really getting this smaller one implicitly. There's not like an explicit error that happens here. So what happens is, why do I have to type short on the left side? The compiler knows the type on the right side, because if I put the wrong thing on the left side, the compiler complains. Why do I have to retype it on the left? So what I do is just put auto. Auto, what it does is it figures out the type on the right side and automatically uses it on the left side. You don't have to retype anything, which is nice. In fact, auto is almost shorter in terms of the number of characters to write than any other type that you'll use. So if I compile this, it compiles just fine. Oops, I actually didn't even save. So it did. That's not the same program. Okay, so that's a different error, but we're not getting a conversion error anymore. We're not getting something that's too large to be represented by a short. So a short can take a value maximum at 32,000 something. But this one can definitely be stored in some integer data type. So this is something different. I'll get to this in a second. But if we actually run this, it actually works. So here, what we're doing is it's automatically figuring out the type and putting it on the left side for us. So I'll get to this C++11 business in a bit. But so this is actually really nice. I don't have to type int or anything, and then everything will work fine. And so I can use auto to get things from other variables. If I have a double here, auto will figure it out for me. Where can this be really useful other than saving us some typing and compiling issues? What if I change this 12 at some point to 12.5, 12.5? So what would I do in normal code if I just wanted 12 to be represented by something? If I ignored auto, what would I use? Just an int. So if I use something like this, or it's called length, I guess. If I use this, then it'll be 12. But what if I did that at some point later? It would actually truncate it, right? Because that's how ints work. They don't store the fractional part. So then I would have to change, again, this to be double. But why do I have to? The compiler knows the type on the right side. So just use auto. It saves your life in more ways than you can even think of. It's a savior in C++ to use auto. So if you recompile, it automatically makes length a double type. It doesn't. You don't have to worry about changing it in more than one place, which is nice. Okay, so I'll return to this. So you may have seen this auto type specifier is a C++ 11 extension. Anyone happen to know what in the world that means? Yeah. So recent versions of C++ have been coming out. And one of them is called C++ 11, came out in 2011. So what happens here is that as features are being added, what you can say is, I want my standard version of C++ to be C++ 11 or a later version, whatever version you want. So what is happening here is that auto was introduced in C++ 11. So what you do here is, in the command to compile, what you do is you say dash std equals C++ 11. And so what this does is it says, okay, I want to compile this file, and I want the standard version of what you're going to be parsing this file as to be C++ 11. Okay? So then if we compile, and then everything will work fine. So it was just giving us a warning here because this thing came out in C++ 11 and you didn't actually say so, so you probably should say so when you do this. So if you're going to be using C++ 11 code, and we will be, you should do this. Any questions on auto or doing this? Yeah.
Is there any reason that you shouldn't use an auto?
Great question. You want an answer? All right. So when would you not use auto? Anyone have an idea? Yeah.
Suppose you had a program that was designed to round, but you wanted to intentionally turn a 12.5 into a 12 or something.
Yeah, so you mean truncate, but you're right. If I want my program to intentionally round down, then auto's probably not what you want here. Another reason why you wouldn't want auto is, what if we had some complex expression over here and we don't know exactly what the type of it is, and I just save it to something called auto? Well, that may be harder for someone using your code to understand, because they just see auto here, and then I see length right here. It's easy enough for us to read this and understand. It's a double, but what if it was something complex and not easy to understand? How do we know what length is? How do I know how to use it? So it may be difficult there, yeah.
Are we allowed to use functions on autos?
Use functions on autos.
So like all the functions like etc. Are we allowed to use them?
Good question. So that's actually a very deep question. So what happens here is, let's just say we have a string like this, George Washington again, and then we wanted to see out the length of the string. Dot length only works on strings, although that's not technically true. For what we know so far, it only works on strings. So auto, all it does, it figures out the type on the right side and uses that on the left side. It's not like a brand new data type or anything. So, so for like things like dot length or dot assign, those are only specific to strings. So when we get to more complex data types where we can define, say, a dot length function like this, then it could be expanded to multiple things. But for now, it only works on strings. So all we really care about auto is that it saves us typing and headaches down the road. Yeah.
So in this case, if we put auto string and then another CN, and then we have to apply, what happens to your CL? So if we didn't define it as uncoded,
I know what you mean. Okay. So if we wanted to do something like this, so let's just say CN stir like this won't work. So, and actually I can show you that it doesn't work. Oh, I didn't save it. Oops. Yeah. So what happens here is that auto, how does auto work? It looks on the right side to figure out the type and then puts it on the left side. Is there a right side here? No. So how does it know what type to put? And in fact, even if somehow it did, can CN take any input? It can take an int, it can take a float, it can take a string, it can take any type. How does it know what type to put for str? So it actually doesn't know. So whenever you want to use auto, you have to initialize it to some value, right at the beginning. So I can do this, and then do the CN right here. That works fine. That'll work just fine, and I can even show you that it works fine. Oh, okay. Yeah. I think I know what happened there. Yeah. So I think you asked this question last time, or someone did. I don't know. Maybe it was you. What is the type of this thing on the right side? Did anyone look? So I invite you to look. What is the type of something that's between two double quotes? And in fact, it's not a string. So when I did this, what auto deduces right here is not actually a string. It's something else. So then, as I said, when you call dot length on something, it only works for strings. But this thing is not technically a string. So it doesn't have a dot length function to work on it. So that's why when I did this, if I save it again, that's why when I did this, we get all these errors, because it's not actually a string, unfortunately. But so this is actually a reason why you would not want to use auto, because here the right side is not actually a string, but I do want to use it as a string. So you do explicitly put string on the left side. And there's a whole host of reasons why you can actually do this conversion and why this works. We're not going to get to that yet. I keep saying that, but I promise you we will get to it. Any questions on this, though? Yeah.
Also, so when you declare the str and then you say CN and str, does that work?
Yeah, this will work just fine. I'm going to eat my words, obviously. But so if we... okay, yeah. Why did it print 3? Because there's a space in there. So Ben has 3 characters. And in fact, we know that it did work because George has 6 and this has 3. So yeah, this definitely works. Any other questions? Okay. So let's get back to this. So the remainder of these slides are just things we kind of can infer or are really simple things. So remember when I said that when you make a variable, you can't use that variable before it's declared. You have to use it after when you declare it. That's something called scope. So the scope in general is you declare a variable somewhere in the program, and then the scope of that variable is everywhere where you can actually use that variable. So what we have seen so far is the scope of a variable is you declare it somewhere, and then the scope of the variable is from there all the way through the rest of the program. That's what we know as scope so far. So when I declare this variable called str, I can use str from line 7 in this case all the way through the rest of the program. That's the scope of the variable. Okay? So scope, all that means is where can you actually use it. So in this case, num1 is okay because I'm using num1 after the declaration in the first line up here. And num2 is having an issue because I'm trying to use the variable num2 before I declare it down here. So the scope of num1 is from line 1 down, and the scope of num2 is from what line to where? Line 4 in this example, and down through the rest of the program. Okay, does that make sense? There's an expanded definition of what scope actually means, but we're not there yet. It's just from where it's declared all the way down. So this may be useful for you for assignment 1. So comments are just a way of documenting the program. What is the program actually doing? So the only purpose of comments is to provide the person reading it some information about what's happening. That's all it does. So comments are, all they do is indicate the purpose of the program, describe variable usage, explain complex sections of code, that sort of thing. They're ignored by the compiler. So they are literally only for human purposes. What happens is when the compiler starts working through your program, it first deletes all comments from your program. Okay, so it just completely ignores comments, as if they don't even exist, because it doesn't have any information for the compiler to make the program actually compile. So they're only for the person reading it. Okay, so what types of comments can you actually use? So there are actually two types of comments. One is called single line. So single line means you start with these two slashes, which are called forward slashes from bottom left to upper right. They're not backslashes, remember, because backslashes have a different purpose. Forward slashes, if you start with two forward slashes like this, the comment goes until the end of the line in the file. So if we wanted to do a comment in this program, let's say I would do two forward slashes and then let's just say getting input, for example. And then down here I can say print length of input, for example. So notice the nice thing about this text editor, Sublime Text, is that it color codes everything automatically, which is kind of cool. So the comment here is in dark gray. And notice that once I start with these two forward slashes, it goes through the rest of the line, but not onto the next one. So single line comments really are single line comments. Okay, so it doesn't have to be on a new, completely new line like I just did. You can have them right after a statement ends, that sort of thing. So here are some more examples. And you can have it on a new line like this. Nothing special there. But if you want to have a long comment, what you can do instead is something called a multi-line comment. And what you technically could do is write a whole bunch of single line comments if you wanted to, but that's kind of cumbersome and a little hard to read. And the purpose of comments is to make the program easy to read. So what you can do is something called a multi-line comment. Okay, so instead of two forward slashes, instead what you do is you have a forward slash star, and you just keep going as far as it goes until you see a star forward slash. So it doesn't matter how many lines that takes. It just keeps going until it sees a star forward slash. So they can span multiple lines. So here's an example. So the multi-line comment starts right here because it starts with a slash and then star, and then it continues through the first line, second line, and third line up until this star slash over here. So that's a multi-line comment. So instead of having to put slash slash on every single line, you can just do this and it's a lot easier to understand. Yeah, you can use them as single line comments, but why bother at that point? So you can have one of either. It doesn't actually matter, but if you really want something with multi-line comments, this is much better than just doing a bunch of single line ones. Okay, any questions on comments? Okay, so just a brief rundown of operators, arithmetic ones, namely. So if you want to do some calculations of some kind, you use arithmetic. So what happens here in C++ is has 3 different types of operators in the general sense. It has what are called unary operators, binary, and ternary operators. So what are those? So unary means that there's a single operand. This operator works on one thing and one thing only. So like -5, for example. What is the operand in this case? What is the operand? It's the 5. What is the operator? The negative. So the operator is acting on 5, and then the result is -5. So the operator here is called unary. It's operating on one thing and one thing only. But we have binary operators. Namely, it works on 2 things. So like if we wanted to do 7 plus 3 or 13 minus 7, then we're working on 2 things. In the 13 minus 7 example, what are the operands? 13 and 7. What is the operator? The minus sign. So in fact, what you can see here is that the minus sign can take on 2 different roles. It can either participate in a unary operator, as a unary operator, or as a binary operator. So you can actually see the power of C++. It could change different operators to do what you want them to do based off of just programming that into the language. Like if we put this directly next to a number, we mean that to be a unary operator, but if we put a space in between, for example, this is a binary operator. So that's kind of cool. But what is this ternary operator? So we're going to get to what this actually does. I'm not going to say it here unless you're curious. But just know that we can operate on 3 things at the same time instead of 2. So we'll get to what this is because it's the subject matter of the next chapter anyway. Any questions on operators? We'll get to what the modulus operator does. So if you look at the operators, the first 3 carry through as you expect. There's no difference depending on any data type that you use between plus, minus, and multiplication. There's no difference there. But there's a slight difference with division. So actually look here. Look at division's example right here. Ignore the answer. What is 7 divided by 3 normally? 2.3333 infinitely, right? Why is it 2 here? Right. So what happens here is something called integer division. So what happens is if both of the operands of the division here are both integers, doesn't matter what type, as long as they're both integer types, then what happens is integer division. So what happens is you do the division normally and truncate the result. So if we look at, say, 2 divided by 4, that's normally 1/2. But if you truncate 1/2, it becomes what? It becomes 0, which is what we display here. But if either operator is floating point, double float, doesn't matter, then what happens is everything is upscaled to be floating point. So if you have one of them being floating point, in this case, by putting a .0 here, then the computation becomes the correct one. It does everything correctly as you would expect. So sometimes you do want integer division, sometimes you don't. So as an example, if you input the number of minutes, let's say you want to calculate the number of hours and minutes that something takes, but the user only knows the number of minutes in total. So what you would do is you would divide by 60 to get the hours and truncate the result. So then that's an example of integer division. So sometimes you want integer division, sometimes not. But the vast majority of the time, you'll encounter something like this, integer division, unintentionally. So what you would do is you would upscale one of them to be floating point. Another way you can do the second thing is to say the same computation as before times 1.0. That's another way you can actually do it. And it doesn't change the value of the result that you want. Any questions on integer division? So this only happens if both of them are integers. Yeah. We'll get to that, yeah. So what is this percent thing? Anyone happen to know what this percent thing actually is? Yeah.
It's like the remainder.
Right, exactly. So the percent thing actually is something called modulus, or as you may know it, the remainder. So if you divide, let's just say 13 by 5, what is the remainder for that? 13 divided by 5. The remainder. It has to be an integer. In this case, it's actually 3. So if you do, as an example, 9% 2, that's the remainder when 9 is divided by 2. Well, since 9 is odd, the remainder must be 1. So percent actually requires both operators to be integers, because if you divide a floating point by another, or it doesn't really matter, as long as one of them is floating point, what does the remainder actually mean there? Because it's doing the exact division now. So it actually doesn't really make sense for one of them to be floating point. So it has to be both integers here. Okay, so this is actually really useful. So what you would want sometimes is maybe you want to execute some code based off whether the user's input was odd or not. So what you can do is say, if the user's input mod or %2, if that result is equal to 1, then you know the input was actually odd. Or if they enter, if you want to calculate if a year is actually a leap year or not, a lot of those calculations involve doing modulus or the percent operator or remainder. Any questions on what remainder actually does? Okay, so let's see how far we can get into constants. So far we have variables that can obviously change, they can vary. But what if you wanted something that you can definitely be sure never changes throughout the course of the program? Either unintentionally or intentionally. It cannot be changed. So that's where constants come in. So as an example, if you wanted to know like the area of a circle, does the value of pi ever change? Although some legislators may think otherwise, but because some of them have tried to legislate that pi is equal to 3 unintentionally, but that's another story for another time. But pi is an example of a number that does not change. So what you would do is you would declare a constant. I don't know why it's called variables here, because that doesn't make sense. You declare a constant that has the value that you want, and throughout the course of the program, it never changes. And if you try to modify it later, it's a compile error. And so therefore, it definitely won't run. Yeah, variables that can't be changed. You should have the descriptive names as always. So the way you do this is, instead of just saying double tax rate equals whatever, you put const, a keyword called const on the front here. So this just says, I'm going to declare a constant, so it'll never change, called tax rate, and it's initialized to this value, and it'll never change that value. So obviously you can see why the first one makes sense. The second one may not make sense if Puerto Rico ever becomes a state, but that's another story for another time. Any other questions? Yeah.
So is that something that you'd have to state prior to putting the rest of your code?
Yeah, you have to put this in. Yeah, it has to be when you compile the program.
Oh, my question was kind of the same. I was just going to ask if you could like assign a constant by the input.
No, you can't. Yeah. Although there's a weird thing related to that, I can tell you offline. Other questions? All right, I'll see you on Friday.